algebra students, Mr. Lawrence here, and we're going to do a should be a refresher lesson, something from last year, but I know many of you, weren't as mature as you are now, and maybe you didn't master it. Or maybe it just didn't click last year. Nothing to do with maturity. You did your best, and maybe you didn't get to spend enough time on it. Whatever the case may be, we're going to go over parallel lines again. Parallel lines cut by a transversal, but I want you to make some flashcards for this. And on the flashcards, you're going to have one flashcard that says vertical angles. That's a symbol for angles. You're also going to have alternate, interior angles. Okay, there will be corresponding angles. Corresponding angles. I'm forgetting. I know there's alternate exterior. Oops. Sorry. Exterior angles. Okay. And when you have these are all different types of congruent angles. And I'm going to show you how to identify them. It's really easy, but you got to put the name with the hint I'm going to give you. Okay, some other things you should have on your flashcard. You should have adjacent, the word adjacent. Okay, I would also include complementary angles. Complementary angles. Okay, and supplementary angles. Oops. Supplementary angles. All right, and I've got some really cool ways to remember these. I'm going to go over the definitions, and I'm going to show you different ways to use them. Now, vertical angles, the ones in red are all congruent to each other. Vertical angles make an X. If you find an X, you know that the angles across from each other are congruent to each other. Not all four angles, just the ones across. So these here are congruent to these here. And it doesn't matter how the X is oriented. It could be a long, kind of flat X like that, or it could be a real tall, skinny X like that. All right, any way the X is oriented, you know the opposite angles are congruent. Now, when you have corresponding angles, you're going to think of the letter F, because when you have corresponding angles, inside the F here, this angle and this angle are congruent. They have equal measure. Okay, now the cool thing is, the F could be a backwards F. It could go like this. Okay. Those two are congruent. It could be an F laying on its back getting a suntan. Okay. And if that's the case, these are congruent. Now, let's see, is that all one? Yes. The F's could be turned like that. They could be like that, laying on its face and upside down and backwards. They could be like this. Bonk. They could be like that, which you already know because we already did. They could be any of those ways, okay? The F can be any of those, and they're congruent. So corresponding angles make an F. You know, it's not an actual definition. The definition of corresponding angles are congruent angles that are formed when two parallel lines are cut by a transversal. Okay, that's what's going on. But here's how you identify it. Now, the alternate interior angles, they make a Z. Okay, but the Z could look more like an N. Then again, it could look like a backwards Z. Backwards N, excuse me. Okay. Or a Z. Or they could look like a Z. Or they could look like a Z. All right, it doesn't matter. As long as you can find a Z in there. Those are alternate. By the way, what does alternate mean? It means to switch sides or in replace of. interior, inside. So they're the ones on the inside of the letter. Okay, alternate exterior, I don't have a letter for, but if you have two parallel lines and they're cut by a transversal, okay, the exterior means they're on the outside, and so if I pick this angle, I'm going to go to the other side of the parallel lines, and then I'm going to alternate over the transversal, and there you go. These two angles will be the same. Okay, these two angles here will be the same. Why? Because they're alternate exterior angles. Definitely make some flashcards for these. All right, adjacent. That is a fancy way to say next to. Next to. All right, just means the angle next to it. So if I take this and I call this angle 1, then and that angle 2, angle 1 and angle 2 are adjacent to each other. So are angle 1 and angle 3. Okay, complementary. Complementary are two adjacent angles that make 90 degrees, and it is so easy to remember this. Watch this. So let me rewrite this. I'm going to write complementary a little bit larger. Two adjacent angles, two angles that are next to each other, that whose sum is 90 degrees. You know how it's so easy to remember? Because there is a 90 hidden in the word. See it? In complementary, there's a 90 there. So it's two adjacent angles whose sum is 90 degrees. Supplementary, supplementary angles are two adjacent angles whose sum is 180 degrees. And you guessed it, there's a little 180 hiding in here. Ooh, I see the 8. I see the 0. Oop, the 1 must be invisible. 180 degrees for supplementary. Let's go and see how we use this. I don't know about you, but I love this stuff. Okay, so I've got to fill in all these other angles here. Let me put little names on it. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, and S. And there we go. All right. Now, right off the bat, I have an X. Do you see my X? Where's my highlighter? Let me highlight my X. I have an X here, and I have an X here. Right off the bat, I know angle C and angle is 62 degrees because it's congruent to this angle here because they're vertical angles. 62 degrees, vertical angles right there. Okay, now there's lots of other X's on here, but I want to show you some other examples. Let's go ahead and find a pair of alternate exterior angles. Okay, all right, here's some parallel lines, right? And here's my transversal. Now I know that this angle here is 62. That was a poor choice of color. Let me change that color. Okay, that's a little better. That's 62. Here's the parallel lines, right? That's the transversal. A transversal is just a line segment or a line that cuts parallel lines, goes through them. Okay, so I need to go to the other side of the parallel lines and then go to the other side of transversal. I need to alternate. This angle here must have the same measure. So it is also 62 degrees. Okay. Now, by the way, I'll bet some of you are going to say, hey, Mr. Lawrence, I wouldn't have done it that way. I would have said I have an F. And you would be absolutely correct. There's going to be lots of different ways to explain why two angles are congruent. All right, let me get rid of that. I'm trying to get rid of these highlightings. And if you look right here, highlighter, where are you? If you look here, there's an F, which forces angle C and angle G to be congruent. Okay? Now, I think I see a Z. Let's see here. Look at this. Yep, there's a Z. So angle C is 62 degrees, but so is angle D. So is angle D, 62 degrees. Okay. Now I see another, I'm going to go with an upside down F this time. Oh, look at my upside down F. This is so crazy. Okay, I'm going to go like this. And there's what would be the top of the F, and there's the bottom of the F. I love how my highlighters blend, but I don't really need them blending for this. Let me move that. So these two angles, D and H, are congruent to each other. Okay, they are corresponding angles. Corresponding. So these are 62 degrees. Now, some of you might get stuck here. There's no reason to be, because remember, there are 180 degrees in a straight line. And if I look, this is 180 degrees. Right? There's a straight line. That's 62. If I did 180 minus 62, I would get 118. So angle A must be 118 degrees in measure. I'm using the fact that the 62 degree angle and angle A are supplementary. Okay, I could have said that about angle A and C also. Now B and A are vertical to each other, so that makes B 118. B and E are alternate interiors. See the backward Z, 118 degrees. Okay, now I could go B and F are corresponding. That'd be 118. Okay, now I can't do J right off the bat. I can do I can use supplementary angles here, 118 degrees. I'm going to come down over here and see if I can fill out some of these, and then that'll allow me to figure out J and K. So angle R is 143 degrees because they're vertical. Okay. The supplementary angles, 180 minus 43, I think would be 37. So S is 37. S and Q are vertical, so Q is 37. Q and P are alternate interior, 37. R and O are both alternate interior, so that's 143. M and Q are corresponding, so that's 37. Okay, N would be 143. Now, some of you need to focus here and look and see. I have a triangle here, don't I? How many degrees are in a triangle? Well, hopefully you know they're 180. By the way, why? Why are there 180 degrees in a triangle? Well, let's see here. What is a triangle? Isn't it half a square, a rectangle, half a quadrilateral? Right? If I cut that in half. Now, a square rectangle is made up of 4 90-degree angles, isn't it? Right? 90 degrees here, 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 and here. So therefore, a quadrilateral has 360 degrees. It's true of all quadrilaterals. Well, if I'm talking about a rectangle, I'm talking about half of that. Well, half of 360 is 180 degrees. So if I go back to my picture, I have 180 degrees here. If I add 62 and 37, I'm going to get 99. The angle J must be 180 minus 99, which would be 81. So angle J is 81 degrees. Now M and K are alternate interior, so it's 37. And let's see here. I think I can go this way and add those three together. No, someone telling me 62, but that's bothering me. Yeah, it looks like it's going to be 62, doesn't it? Let's try it. Okay. Yeah, 62 is probably right. 81 and 37 is 8, 11. So 180 minus 118. Yeah, that's 62. So there's a 62 degrees right there. Okay, I know what was bothering me. I'll have to tell you about that later, not right now. I don't want to throw too much at you. All right, so there's your lesson on parallel lines. You're going to need to know the words corresponding, alternate interior, alternate exterior, vertical, adjacent, supplementary, complementary, and those things will help us figure out the missing degrees. All right, Mr. Lawrence signing off. Have a good night, everybody.